Assalamu alaikum.
Assalamu alaikum. Salam.
Okay, so at the moment there are about 15 students. So let me share my screen with you people. Okay, so here's the main stream. If you go to classwork, so lecture number 8. Today we have to go through lecture number 8, and the slide that we will use, it's given over here. Okay, so how you can download? Click here, open a new window, and then you will get download option. So you can download these slides. Okay, lecture 5, 6, and 7 videos are already uploaded over here. You can see it. And if you look at in assignment section, we are having two assignments. So assignment number one, it is due on July 10, 8 p.m. Okay, let's check out the dates. So we have this week, and then in this week you are having your examination. So I will not disturb you in this as well as in this week. However, after your midterm exam, you have enough time to write down and submit this assignment. So you can submit it on um, July 10th before 8 p.m. Okay, and then again after a week, you have, I mean, after that week, you have to submit your assignment. No, the first, yes, both assignment need to be submitted on that July 10th. So the due time is 8 p.m. and due date is July 10th. Okay, if I click on it, in case of copied assignment, all copied and original assignment from where copied will be cancelled. So don't try to copy it. Okay. All question must be solved step by step with proper explanation and neat and clean diagrams. So what you need to do, you need to explain every step. You need to write down given data, required data, diagrams, free body diagrams, solution. If you want to make any assumption, you need to state those assumptions. Okay. Uh, these problems may be available in your solution manual, but if you directly copy it from solution manual, so you will straight away get 0 marks. And you already know that there are 50% for final, 20 for mid, and 30% marks for sessional. So 30 is like a huge portion, and you can get these marks very much easily if you do those assignments and take home tasks. If you put some effort in it. So if you directly copy it from solution manual without explaining all those steps, like in some solution manual, sometimes they solve 8 to 10 step problem in a single step. So you, if you do it that way, definitely I will give you 0 marks. So you have to solve it by yourself and step by step. If you want to take help from solution manual, you can take. But remember, you can discuss it with your friend, but you cannot copy it from him. In case of copy, I told you the source as well as the copied assignments all will be cancelled. All will get 0. So this is like good opportunity for you people to get sessional marks. So assignment one is here, and then we have assignment two. So there are few questions in assignment one, like 2 questions and maybe 3 questions in assignment two. Walaikum assalam. Okay, so let's go towards our today's topic. Okay, so hopefully screen is there in front of you people. So before this class, what we have done so far, uh, we started with our mechanics, then statics, and in statics we studied forces, then the resultant of forces, how to find out the resultant of forces. Then we studied the moment. Then after moments we studied couple and the net resultant. Okay, so whatever we have done so far, that was basically for a simple system, for a plane system, which is actually known as 2D system. So in today's class, we will move towards 3D force system or 3D system in which we'll be having three axes. For example, in previous cases, we were having XY coordinates or XZ or YZ coordinates. So now we would be having XYZ coordinates, that is three dimension, which is also known as space. Okay, so why we need to do those 3D analysis of forces, why we need to find out the effect of forces in three-dimensional space. So it's very much necessary because in practical scenario you have to deal with 3D systems. So and that practical scenario basically required analysis in three-dimensional space. So for such problem, it is very much important to understand the analysis of forces in three-dimensional space or 3D system, that is having three axes x, y, and z. Why we call it space? Because space is 3D. So for force analysis or to find out the effect of force, usually what we do, we basically find out the component of force. We resolve forces into their respective components. So when we were having xy coordinates, so we were having two force of components, that was x and y. So if we are having three components of space, the coordinate system, that is x, y, and z. So if the force is inclined to these axes, so we can have three component of force, that can be fx, fy, and fz. Okay, so let me maximize the screen. Okay, for example, we have this x-axis, this y-axis, and z-axis. You can change this x, y, and z as per your convenience. But we over here in diagram, I have marked this x, y, and z like this, as shown in the figure. Now, imagine we have a force. This force is not a parallel force; it is an inclined force that is inclined to all those axes. Okay, so if you remember the the case of two axes, the case of 2D. So when force used to incline to some axis, for example, if we have x and y axis and the force is making an angle of theta with x axis, so we used to find out two components of force, that is fx and fy. Fx used to be f cos of theta, y cos because the angle was with the x axis, and fy was used to be f sine of theta because angle is on the opposite side. Okay, in this case, if you look here, this force F, it is making an angle with every axis. It is inclined to y axis, it is inclined to x axis, and it is also inclined to z axis. Okay, so how we can resolve? Let's see with x axis. Look at this force. If it is making an angle with x axis, okay, here it is making an angle, and the angle that it makes with positive x-axis, it is how much? Theta x. So this component fx, it will be simply equal to f cos of this angle, the angle that the force make with x-axis. So fx will be equal to f cos of theta x. Now let's look at the force component in y direction. So the force component in y direction, it will be fy, and again, if you look, it is making another angle, that is theta y with y axis. If we use this angle theta y, so the force component in y direction, it will be fy cos of theta y because the angle is here on this side and we have used this angle. So it will be fy f cos of theta y. Okay. If you observe, this force F is also making an angle theta z with the z axis. So if I want to find out the z component by using this angle, so what I can do, I can just simply find out the cos theta and multiply with the force. So F cos of theta Z is basically that FZ component. So we have these three components: cos theta X, cos theta Y, cos theta Z. These are the three components of forces. Okay. So we can write Fxi, Fyj, Fzk in terms of unit vector. If you want to find out the magnitude, so take square of all those components and add them, and then take their square root. Okay. So Fx, we know that if it is that is equal to F cos theta X, Fy is cos theta Y, and Fz is uh, F cos theta Z. So this is F cos theta X, F cos theta Y, and with the corresponding unit vectors. So by using this method, what we can do, we can find out the components of forces. Okay. uh, समझ आ रही है आप सब लोगों को? If you are not asking any question, I will assume कि आपको समझ आ रही है, and I will move forward. Okay. So what are basically I, J, and K? आवाज आ रही है ना सबको?
Yes, sir.
Yes, sir.
Okay. Okay. So over here, the I, J, and K are basically the unit vector. I is in X direction, J is in Y direction, and K uh, unit vector along Z direction. Okay. Now this theta X, cos theta Y, cos theta Z, since they are with cos angle, so they are basically known as direction cosine. A cos theta X is showing direction in x-axis, means it is basically the angle of force with positive x-axis. Similarly, cos theta Y, cos theta Z, these are basically known as direction cosine of F. So if we put cos theta X is equal to L, cos theta Y is equal to M, and cos theta Z is equal to N, so this equation will become like this: L, M, N. So, and we also know that L square plus M square plus N square, that will be equal to 1. Why? Because if this is a vector, this is the magnitude of vector, so this should be the direction. We know that if we have force, so the force, already we know that that is vector, and vector is having two things: one is magnitude, another one is direction, and for direction usually we use unit vector. So remember, if we add all those components, what we will get? We will get 1. Means take square of all those and then add them, so you will get 1. If you take square root of 1, so still it will be 1. Okay. So see over here. So what I told you, this is force. Force is a vector, so it should be having magnitude and it should be having direction. And per direction, we usually use what? We use unit vector. So unit vector is a vector that is basically having a unit magnitude, that is having magnitude of 1, and it is basically used to represent direction, to show direction of vector. Okay. So this NF is basically equal to this vector Li, Mj, and K. Okay. So whenever we have to solve a three-dimensional problem, usually we need to find the x, y, and z scalar components. So the direction of force can be given by two various methods. Means can be given in two ways. Okay. One of the way is, let me check whether it's recording or not. Okay. One of the way is like we will be having a vector, we will be having force, and the starting and ending point of line of application will be given to us. So by 2 points on the line of action of force, so this is one of the method. Or in other cases, we will not be having those 2 points, that starting and ending of force. Rather than we will be having two angles that the force make with the two planes. One plane can be xy, other plane can be yz, or other plane can be xz, any of the plane. So we will look into these two cases in detail. So let's consider one of the case. For example, we have a 3D space x, y, and z. So what we basically need to do, we need to find out the component of forces, that is component of force along x-axis, then the component of force along y-axis, and the component of force along z-axis. So here the force is inclined. Now we don't have any angle in this case, but what we have the starting point and ending point, or we have any 2 points on line of action. So if we have this x value, if we have that y value, and if we have that z value, mean the difference in x coordinates between the 2 point, difference in y, the two coordinates, and difference in z. So that will be x distance, y distance, and z distance. Okay. So if we have that thing, based on this, we can find out the required vector. So we already know that we have this vector which is equal to magnitude multiplied by direction. So we are having force. Force is basically equal to magnitude multiplied by its direction. So this is the magnitude and this is the direction, and this is unit vector. So if you want to find out the means like the if you want to find out the unit vector, so what is the procedure if you are having any vector given, and if you want to find out its uh, for example, if you are having some vector, you want to find out the unit vector for the corresponding vector. So what you need to do, you divide the vector by its magnitude. How we can find out the unit vector? Divide the vector by its magnitude and you will get the corresponding unit vector. So what we are trying to do, we basically want to find out the vector that is in between AB, or the vector which is actually F. We want to find out the corresponding unit vector along this F. So it can be vector AB divided by its magnitude. So here AB divided by its magnitude. Now for AB, we need this X. If you find out this X distance, that will be XI. If you find out this Y distance, X is this one, Y is this one, and Z is this one. If you find out all those three distances between 2 points X, Y, and Z, so we'll put Xi, Yj, Zk. This will be a vector. And divide by its magnitude. So magnitude will be X square plus Y square plus Z square whole square root. So here, what is X? To find out X, we have this formula x2 minus x1. For Y, we have y2 minus y1. For Z, we have z2 minus z1. Divided by magnitude. So magnitude is x square plus y square plus z square whole square root. So in this way, if you are given 2 points of a vector, we can do the remaining calculation. We can find out the remaining components. So from here you can see, this is if someone asks that what is the x component. So this is the x component, this is the y component, and this is the z component. Hopefully this point is clear to everyone. Okay, you need to understand all those things. If you having some questions, if you are having some query, you can ask me. अपने कंसेप्ट इन चीजों पे क्लियर करना होगा क्योंकि आगे प्रॉब्लम्स इन्हीं चीजों पे आ रही हैं. ओके, सो लेट्स मूव
एक्सक्यूज मी सर.
फॉरवर्ड. जी जी
सर अगर x के 3 पॉइंट होंगे तो x3 माइनस x2 माइनस x1.
नो 3 पॉइंट्स नहीं होंगे, 2 पॉइंट्स आपके पास होंगे. दो वी नीड 2 पॉइंट्स ओनली. इज इट क्लियर? एंड how can be like 3 points? In case of 3 points, those 3 points will be along same line of action of force. फर्स्ट थिंग, सो अगर सेम लाइन ऑफ एक्शन फोर्स में है, सो मींस आप कोई भी 2 पॉइंट्स लेके वो कर सकते हैं. ठीक है? या it's not like about 2 points or 3 points. Means in order to find out the exact magnitude, exact direction of force, in calculation something will be given to us, and in our practical system there might be some data available to us. So that data, it might be in the form of the starting and ending point. So there will be one starting point, there will be one ending point. Is it clear? Means in between point we will not consider. So and the starting and ending point, it will be along the line of action of force. So in this scenario we are not having any third point. Okay, and in our system it might be difficult
Okay, sir.
to locate the starting and ending point. So there might be scenarios where instead of these 2 points we can have angle, the angle that it
Yes,
makes
sir.
with x, the angle that it makes with y. So let's discuss that case. So now in this case specification, a force by two angle which orient the line of action of force. So for example, we have now this force. So in this case, we don't have the starting and ending point now. Okay. So in this specific case, the starting point can be 0, 0, 0, but we don't have the end point. So means we cannot use that previous formula or that previous method. What we need to do, what is the basic purpose? I want to find out the component of this force in x direction, in y direction, and in z direction. So let's see whether this force is making any angle with the x-axis. It's not given. Means there is no direct angle of f and x-axis. If we have, so we will direct consider f cos of that angle. There is no angle between f and y. So again, it's a problem. We cannot find out that fy component directly. If the angle is given, simply f cos of y. So no specific angle with any of the axes is given. Okay. So now you see this f is inclined to all these three axes. Okay. What I need to do, my target is to find fx, fy, and fz. Okay. If these things are not clear to you people at this stage, so you will not understand problems. और अगर वहां पे आप मुझसे ये क्वेश्चंस फिर करेंगे, आई विल नॉट आंसर यू पीपल. ठीक है, तो अगर कोई कंफ्यूजन हो रही है अभी से क्लियर कर दें, क्योंकि एट द एंड आई कैन नॉट रिपीट द होल क्लास. ओके, सो यहाँ पे आप देख लें, what we need to do, we need to find fx, fy, and fz. So we have this angle phi. Okay, so this means this angle will be 90 minus phi. Or if I want to find out the component of this force, so I can find out with this angle, I can find out this component, and I can find out this component. So since we don't have any angle over here, however, the opposite angle is given. So this component fz, that can be equal to f sine of theta or sine of phi. So fz will be equal to f sine of phi. We have find out this one. Now this component is neither x, it's neither y. So we can give this name as fa or fp or fh, or let's say if it is in between xy, so let it give some name like fxy. You can give any name. So now we have fz and we have fxy. So we got these two components. So this is my required component, but fxy is not my required component. What I need, I actually need fx and fy and fz. So I got only one, that is fz. And what I need to find out more, I need to find out fx and fy. Okay, now look this one. So initially I treated this one as a 2D system. This one I simplify for myself. So I find out this component, this component. Now see, we are having this fxy, it is making an angle theta with x-axis. So this force, the component of this force is making an angle of theta with fx. So if I want to find out its component, it will be having two components, one component of this one and one component of this one. So fx will be equal to fxy cos of theta. Fx is equal to fxy cos of theta. And fy will be fxy sine of theta. Is it clear? From here you can see fxy is basically equal to f cos of phi. F cos of phi, f cos theta. Means I put fxy value here and I put fxy value here. So now my required problem is solved. What I wanted to find out, fz, fx, and fy. I got the answer. So you see, in fx, fy, two angles are involved. So in 3D cases, it's not very much simple that you are having two angles and you just directly simple find out like one component will be equal to fx, will be equal to f cos theta, and phi is equal to f sin theta. No, the angle is not given like that. If you have a specific angle with any of the axis, so it's easy to find out component along that axis. लेकिन यहाँ पे हमें general angle given है, ठीक है? So it's very much difficult to do it directly. So what we do? We do it step by step. So now we have that fz, fx, and fy. So put it in the equation fxi, fyj, fzk, and our required vectors is solved. Hopefully this thing is clear to everyone.
सर ये एफ जेड इज इक्वल टू एफ साइन पाई कैसे है?
fz is equal to,
साइन पाई।
okay, this is the angle phi, okay, and force is making it with this plane. Okay, so if I want to find out the perpendicular or orthogonal components of this force, so you see one component will be this one and one component will be this one. Since angle is with this component, so this one will become cos. Let's say this is fxy. So fxy will become f cos of phi. And this component is opposite. So it will become fz will become equal to f sine of phi. Is it clear?
यस सर।
Shahid? Okay.
सर
Yes.
सर प्रीवियस स्लाइड। सर इसमें
जी,
हम मतलब एंगल ये क्यों एज्यूम कर रहे हैं कि एफ सी और एफ एक्स वाई के दरमियानी एंगल होगा। लाइक एफ सी और एफ वाई के दरमियान भी हो सकता है और हम एफ एक्स के साथ उसको 90 डिग्री क्यों नहीं ले रहे।
एंगल क्या हो सकता है, दोबारा क्वेश्चन करें।
सर एंगल हम लोग एफ सी और एफ एक्स वाई के दरमियान ले रहे हैं ना, लाइक मतलब उसके दो कंपोनेंट्स ले रहे हैं, तो हम उसको
जी जी।
एज्यूम क्यों कर रहे हैं कि एफ जी और एफ वाई के दरमियान मतलब वो दो उसके कंपोनेंट्स हैं और जो एफ एक्स के साथ उसने एंगल बनाया है वो
अच्छा,
90 डिग्री।
एक मिनट, हम एज्यूम कुछ नहीं कर रहे हैं। एक्चुअल जो हमें सिनारियो गिवन है, जो हमारे सामने, हम उस पे सॉल्व कर रहे हैं। यहाँ पे हम कुछ एज्यूम नहीं कर रहे हैं। फॉर एग्जांपल अभी एंगल जो गिवन है वो एक्स वाई प्लेन, ये जो एंगल फाई है, दिस इज एंगल दैट एफ मेक्स विद एक्स वाई प्लेन। ठीक है, ये देखिए नीचे वाला ये प्लेन है, आपके पास एक्स वाई प्लेन है। आप अपने रूम को इमेजिन करिए, आपके पास एक 3D स्पेस है, एक वेक्टर है जो जमीन जमीन को अगर आप एक्स वाई कंसिडर कर लेते हैं, ठीक है, अपने फ्लोर को एक्स वाई कंसिडर कर लेते हैं, और एक वेक्टर है, एक फोर्स है जो कि जमीन के साथ फाई एंगल बना रहा है। सो यू कैन नॉट एज्यूम इट लाइक एन एंगल विद एक्स एक्सिस और वाई एक्सिस। इट इज बेसिकली मेकिंग दिस एंगल विद बोथ कंबाइंड एक्स वाई प्लेन। ठीक है, सो ये हमें अभी यहाँ पे सिनारियो गिवन है। अभी इसको मैं नहीं ले सकता वाई के साथ, क्योंकि वाई यहाँ पे है, और ये जो एंगल है आप इमेजिन करें कि ये आपकी रूम की इस तरह डायगनल पे है बिल्कुल। ठीक है, ये जो फोर्स आप यहाँ पे है, सो दिस इज नॉट एन एंगल विद वाई एक्सिस, नाइदर एन एंगल विद एक्स एक्सिस। सो दैट्स व्हाई आई कैन नॉट डायरेक्टली फाइंड एनी ऑफ इट्स कंपोनेंट विद दीज टू। हाउएवर जेड आप देख लें, जेड आप देख लें, आपकी जो कमरे की दीवार की हाइट है, दिस इज लाइक जेड एक्सिस, it is having that angle indirectly, but what is that angle? 90 minus 5. So I can find out that component. Is it clear now?
यस सर।
Okay, so same thing, let's repeat again so you can have some practice. We have this force that is inclined with all these three axes. So this theta y is given, so this force will be having two components. This force will be having two components. This theta y will become f cos of fy component will become f cos of theta y. Fy will become f cos of theta y because angle is on this side, and the opposite the opposite angle on this side in the xz plane, it will become f. Okay, what name should we give it? It can be fxz, fa, fp, fh, whatever name you want to give it. So they have given what name? Cannot see it. Okay, they use fh. So fh is basically this component, and this should be cos of theta y, f cos of theta y. Sorry, so sine, not cos. Why sine here? Because the angle is on the other side. So angle is on this side, this component will be cos, and this one will be sine. So fy will be equal to f cos of theta y, and this fh or fa or fp, whatever name you give it to it, it will be sine of theta y. So these two components. Now we have these two components. One is fy and one is fh. So still we don't have fx and fz. If we get this angle or this angle, so we can find this component, these two components. For example, the angle that it makes with the positive x-axis, if it is phi, so it's very much easy to find out this angle. So fx will become fh cos of phi and fz will become fh sine of phi. So this is fx is fh cos of phi and fz is fh sine of phi. So we already have fh value from here, so we will put this value, and here again we will put this value. So this way we can solve these three-dimension problems if the angles are given to us. Now we already know that if we are having two vectors, this is like very much important step. If you got this step, you can solve almost all problem in this chapter. Okay, if we have two vector and if we take its dot product, for example we have two vector a and b, if we take their dot product a dot b, so it will be equal to a b cos of angle between them. Is it like this?
Yes, sir.
Okay, so ab cos of angle between them. Now we are having two vectors a dot b, but the final output is it vector or scalar in case of dot product?
Scalar.
Sir.
Scalar
Scalar.
means the final output, it is having only magnitude and no direction. So this thing is clear to us. Okay, so you see we have two vectors pq, and the output is basically pq and cos of angle between them, cos of angle between them. So what they basically say, they say that imagine this p, we are having this p, if we want to find out the projection of this p on this q. So projection को तो हम 90 degree पे लेते हैं, we take it as perpendicular whenever you want to measure the projection. So the projection will be like this, and this is the projection. We have this vector, we will project this one here, so the projection will be this one, and the value of projection will be basically equal to p cos of alpha. So means what they want to say means that p dot q is equal to p cos of alpha. We can consider this one as the product of projection of p on q, which is basically p cos of alpha, and a product of q. So what they basically say that the dot product is also equal to the projection of p on q multiplied by q. So the projection of p on q is basically p cos of alpha. Or we can do the same as reverse, that the projection of q on p multiplied by p. So the projection of q on p is basically q cos of alpha multiplied by p. In both cases, if you put p cos of alpha multiplied by q or q cos of alpha multiplied by p, in both cases you will be having same, because this is magnitude, this is scalar product. So that's been explained over here. What they are saying, we can view this product either as orthogonal projection p cos of alpha of p in the direction of q multiplied by q, or orthogonal projection of q cos of alpha of q in the direction of p multiplied by p. So you can consider it either way. Okay, now you see, we know that in previous case when we were discussing, when we were having direction cosine, so fx was equal to f cos theta x. Remember this one from the initial slide? Fx is equal to f cos of theta x. Is it like this?
Yes, sir.
Yes, sir.
Okay, now what is this cos of theta x? This is basically direction cosine. This is direction cosine, means whenever we have a vector, so vector is basically represented by two things, and those two things are basically, one is the magnitude, other one is the direction. Okay, imagine this is f, and this is basically the magnitude, and this one you can see the projection of this force, or the fx on I. Instead of this, if I write like fx is equal to f dot I, so what will be the output? The output will be fi cos of angle between f and I. It will be like this. और से सुने, let me repeat. We have fx is equal to f dot I. Imagine if we have f dot I. So since there is a dot product, the output will be f I cos of angle between f and I. So imagine the angle between f and I, which is like the x-axis. If it is theta x, if the angle is theta x, so what will be the output of f dot I? It will be f I cos of theta x, right?
Yes, sir.
Okay, समझ आ रही इस चीज की?
Yes, sir.
Okay, so f dot I,
Yes, sir.
it will be equal to f I cos of theta x. Now what is I?
सर यूनिट वेक्टर 1 वैल्यू हो जाएगी.
Okay, this is unit vector in the x direction, so its value will be 1. So we can say that fx is basically fi cos of theta x. Since I is 1, so fx is equal to f cos of theta x. Is it like this?
Yes, sir.
Okay, so instead of this one, we can also write it like this one. So if, let's say, someone wants you to find out the component of force F, the component of force X in X direction, so what you can do, you can find out the unit vector in X direction and take its dot product with the force. If someone asks you to find out the component of force in Z direction, so what you will do, you will find out the unit vector in Z direction and multiply it with force. Is it right?
Yes, sir.
सबको समझ आ रही है ना इस पॉइंट की? अब्बास?
Yes, sir.
Okay. For example, we don't have x, y, z axis. We have some axis like n, or we have an axis t, or imagine we have an axis with a name. Uh, let's say the axis name is p axis, and I want you to find out the component of force along p axis. So that may be very much difficult to find out the component of force in p axis. The component will be fp. So in order to find out, what I will do, I will simply find out the unit vector along the p-axis and will take its dot product with the force. So it will become f dot unit vector along p, f dot np, and I will get that component of force along p-axis. Is it clear? If I want to find the component of force along x-axis, so what you will do, you will find out the unit vector along along x-axis, which is I, and you will take its dot product with the force f dot I. You will get fx component. Is it clear?
Yes, sir.
Okay, so remember this step. If you want to find out any component of force along any axis, so what you will do, find out unit vector, take its dot product with the force.
सर यूनिट वेक्टर हमें गिवन होगा या फिर उसको फाइंड करना होगा?
अगर गिवन अच्छी बात है, अगर नहीं गिवन तो वी हैव टू फाइंड इट आउट.
फाइंड कैसे करेंगे सर?
तो फाइंड अभी आपको मैं बता दूंगा, आपको मैं एग्जांपल्स प्रॉब्लम्स करवाऊंगा, आप उससे देख लीजिएगा.
सही है सर, थैंक यू सर.
ओके, सो इस पे भी प्रॉब्लम्स करेंगे, आपको क्लियर हो जाएगा. अच्छा देखिए, अभी दो वेक्टर्स का आप डॉट प्रोडक्ट लेते हैं तो उसका आउटपुट क्या होगा? स्केलर होगा. तो यहाँ पे देखिए, फॉर एग्जांपल वी हैव दिस फोर्स एफ, एंड मैं चाहता हूँ कि मुझे ये जो एक्सिस है एन, ये जो एक्सिस है एन, इसके अलोंग इसका कंपोनेंट मिल जाए. तो वो क्या होगा? वो कंपोनेंट निकालने के लिए मैं सिंपली आई विल फाइंड आउट द यूनिट वेक्टर अलोंग एन and will take its dot product with the force. So you see, Fn component क्या होगा? F but into dot product of unit vector along that axis. इस पॉइंट की समझ आ रही है? ये पॉइंट क्लियर हो रहा है
यस सर,
सबको?
यस
अच्छा,
सर।
बट ये देखिए, ये क्या एफ डॉट एन से क्या आएगा हमारे पास? स्केलर हमारे पास आएगा। स्केलर का मतलब क्या? सिर्फ मैग्नीट्यूड आएगा। ठीक है। सो इफ समवन आस्क यू इन द क्वेश्चन टू शो योर आंसर इन द वेक्टर फॉर्म, एफ डॉट एन विल गिव अस scalar. If someone asks us to show your answer in vector form, so what will be the difference in vector form? Along with magnitude, we have to put the direction, and for direction, what we need to use? We need to use unit vector. Am I right?
Yes, sir.
Okay. So you see here, f dot n, it will give us magnitude. Whatever magnitude we get, we will put a unit vector with it. So you see here, fn is equal to f dot n into n. So that f dot n, it will gives us the magnitude, the scalar component, and this extra n, it will basically show the direction. Is it clear now?
जी सर।
Okay. So I have explained it over here in more general form, in more general terms. If n is a unit vector in a specified direction, the projection of f in n direction, figure 219b, has the magnitude fn is equal to fn. This is the magnitude. If you want to express the projection in n direction as a vector quantity, then we multiply its scalar component expressed by f dot n by unit vector n. So we will get this fn is equal to f dot n, and to show direction, we put another n with it. So we may write this one as fn is equal to f dot n n. Okay. So imagine we have a unit vector, and if you are having a direction cosine of unit vector like alpha, beta, gamma, means for previous case, if you remember, for force we were having three direction cosine, which we represent with L, M, and N. So imagine for unit vector, instead of L, M, N, we use some other words like for direction cosine. Let's say it be alpha, beta, and gamma. So the unit vector will become AI, alpha I, beta j, and gamma k. And for force, you remember the direction cosine were L, M, N. So the force become L, I, M, j, N, k. If we take dot product of both of them, it will be like this. So this will multiply with this one, then L, I will multiply with this one, then it will multiply with this one. So we know that in case of dot product, if we have I dot I, so the angle between these two will be 0, and cos of 0 will give us 1. If we take I dot j, j dot k, I dot k, k dot I, k dot j, in all of these, the angle between these two will be 90 degree, and cos of 90 will be 0. So I dot I is equal to j dot j is equal to k dot k, it will give us just 1. Remaining all will give us 0. So when this Li, alpha I, it combines, we will get La and M beta and N gamma, these things. This is just to remind you that dot product concept. Okay. For example, if we want to find out the angle between two vectors, we have vector 1 and we have vector 2. So what we will do, if we take dot product of these two vectors, A dot B, so the output will be AB cos of angle between them. So to find out angle, what we will do, we will take that A vector A dot vector B divided by its magnitude AB, that will be equal to cos of angle between them, right? Are you getting me? Is A dot B is equal to AB cos theta, so cos theta will be equal to A dot B divided by AB. Is it like this?
Yes, sir.
Okay. So if I want to find out the angle, so what I will do, I will keep the angle on one side and will shift the cos to other side. So theta will be equal to cos inverse A dot B, means A and B are vector, divided by AB, which is the magnitude. Will it be like this?
Yes, sir.
Okay. So same is the case. If we want to find out angle between any two quantities, so here, like you can see, theta is equal to cos of inverse A dot B divided by AB. A is F, B is N. Divided by AB, A is F, B is N. And we know that N magnitude is 1. So that's why I haven't put N over here. Is it clear?
Yes, sir.
Yes,
In
sir.
this case, we have two vectors P, Q. So the angle is basically equal to cos inverse P dot Q divided by PQ. Means P dot Q is equal to PQ cos of theta, and theta is equal to cos inverse P dot Q divided by PQ. So you can find out angle by using this method. Now, let's go towards a sample problem. So we have a sample problem 2-10. This is in your book. A force F with magnitude of 100 Newton is applied at the origin O, applied over here, of the axis X, Y, Z as shown. The line of action of force passes through point A, means through this point, where coordinates are 3 meter, 4 meter, and 5 meter. So means the distance between these two is basically given here. All coordinates are 0, 0. So the distance in X is 3. The distance in Y till this point A, it is basically how much? Let's see. It's not given here. Oh, here. It is 4 meter. Okay. And the distance in Z direction, it is about 5 meter. What we need to do, determine X, Y, and Z component of force. Okay, so it's very much easy, like to find out. Like we have this force, and force is basically equal to force multiplied by its direction. Force into direction. So we already have force magnitude 100 Newton. So we have 100 Newton, and we need to find out its direction. So for direction, we use unit vector, and you already know unit vector is basically equal to vector divided by its magnitude. For any vector, if you want to find out its unit vector, take the vector and divide by its magnitude, so you will get the unit vector. Now, how we can find out that vector? We have this x component, we have this y component, and we have this z component. So 3i, 4j, and zk, that will be the vector. I mean, 5k, sorry, not zk. 3i, 4j, and 5k, that is the vector. And divide by its magnitude, so 3 square plus 4 square, 5 square, whole square root. So the magnitude is already 100. From here, what we will do, we will find out the unit vector. That is basically the unit vector. Multiply with the magnitude, you will get the required vector. So this is x component, this is y component, this is z component, which was asked in the question. Find the x, y, and z scalar component of f. Do you understand this point? Is it clear till this point?
Yes, sir.
Yes, sir.
Okay. Let me take attendance, then we can move on. Okay, so now, so the x, y, and z components are here. Now what they basically want us to do, find the projection fxy of x. Okay, let me repeat the projection fxy of f on the xy plane. So whenever you got a question like this, find out the projection of a on x-axis. Projection of a on x-axis. So for projection, we usually use the cos angle. So this means find out, basically, if someone asks you to find out the projection of A on B axis, this means find out the component of A along B axis. If I want you to find out the projection of F on x axis, this means I want you to find out the component of force F along x axis. In other words, I want you to find Fx. So what they are asking, they want you to find out the projection of f on the xy plane. Means they want you to find out component of force along xy. Is it clear? So fxy, it will be simply equal to f cos of theta between f and x-axis. xy plane. किस चीज के बराबर होगा? The projection will be fxy will be equal to f cos of angle between force and xy. So let the angle be theta xy. So this is the thing. We have f, but we don't have theta xy, right? So in order to find out the theta, the angle, we know that how we can find out. We, for example, if I want to find out the angle between AB, so A dot B is equal to AB cos theta. Cos theta will be on one side, A dot B divided by AB will be on the other side, and then cos को दूसरे side पे shift कर दे, it will be cos inverse. So over here, what I want to find out, I want this angle, the angle that force make with xy, means I want to find out this angle. Is it clear what I want to find? I want to find out this angle. So to find this angle, this will be the base, and this one will be the perpendicular, and this one will be the hypotenuse. So I will get a right angle triangle like this. For example, this one. I want this angle theta xy. So this one will become my base, this one will become my perpendicular, and this one will become hypotenuse. Is it clear? So in case, in simple trigonometric ratio, cos theta is basically equal to base by hypotenuse. Base by hypotenuse. Okay. Now, how much is this distance? How much is this distance? So I need to find out this distance. How I can find out this distance? I know this distance, this one, which is 4. I know this distance, how much it is? It is 3. So I know this and this. So can I find out this one? G, can we find out this
Yes,
one?
sir. Yes, sir.
How? How
Sir,
can?
thank you, Restaurant.
Yes, very good. So this one is 4 square. This one will become 4 square plus 3 square and whole square root. Is it clear? So we will get this one. So means this distance will become square root this square plus this square, which is 4 square plus 3 square. Okay. If we get this one, can we find out this one? How we can find out this one? This whole square plus this square and whole square root. It will be like this. So this distance, we already know this distance is 3 square plus 4 square square root. And if I want to find out this one, so what I will do, this one plus this one means square of this one plus square of this one and whole square root. So I will get this distance. So now I get this piece, I get a hypotenuse, and that will be equal to cos of theta xy. So cos of theta xy is equal to base divided by hypotenuse. So from here I get 0.707. For projection, I had this formula. Now I get this theta xy. I will put it over here and I will get the required answer. Is it clear?
Sir, please repeat part B.
Okay. In part B, what they are basically asking, they are asking find the projection of F on the xy plane, which means find out the component of force along xy plane. Okay, means along this one. So if I want projection of this force along this plane, I mean for this purpose, I need this angle, the angle that it makes with this plane. Okay, so let's say this is the angle. This is the angle, this one. So for this angle, if I draw it like this, it will become right angle triangle. I need this distance and I need this distance, right? So I don't have this distance. I have this distance already. I have this one is 5, but I don't have this one, but I have this distance and this distance. So you see, this one is like right angle triangle. So by using Pythagoras theorem, I can find this distance. Now, when I get this distance, I will be having this as well as this one. So I can find out this distance again by Pythagoras theorem. Okay, so for this distance, what I will do, this square plus this square, square root. This square plus this square, square root. And So this will become base, and hypotenuse will be this plus this square plus this square root. So this one is 3 square plus 4 square and plus this square root. So base by hypotenuse, we will get this answer. Is it clear now?
Yes, sir. Thank you.
Okay. So put it in the equation. Fxy is equal to f cos theta y. So this is basically a projection or the component which they were asking for. We find it out, this one. Now what they are asking? They are saying the projection FOB of f along the line AB. Now they want me to find out the projection of f along line AB, line OB. In other words, they want me to find out the component of force along line OB. So for example, this is line OB, right? I want to find out component of this force along line OB. So I told you a very simple step. If you want to find out the component of F along P, what you will do? What will be the step?
Sir, we will
Find out
it and then multiply it.
find out unit vector along axis P, take its dot product with the force. So now what I want to find out component of F along line OB. So find out the unit vector along line OB, which will be NOB. Is it clear? And take its dot product with the force. So that will be FOB. So let's see. What I want to do, I want to find out the unit vector and OB. So how I can find out the unit vector and OB? So for unit vector, what you need to do, you need vector and its magnitude. So take vector divided by its magnitude, you will get the unit vector. So means for this one, we have this x value from point O to B is how much? 6. So it will become 6i, and in y direction, how much is the distance? 6. So it will become 6i 6j, and in z distance, how much is, like in z direction, how much is the distance? 2. So the unit vector will become 6i 6j and 2k. 6i 6j and 2k divided by its magnitude. So we will get this unit vector. We already have force vector. This force vector. So force vector, take dot product with the unit vector, and you will get this magnitude of projection FOV. Is it clear, this one?
Yes, sir.
Okay.
Yes, sir.
Okay, so when we take the dot product, what we get in the
Excuse me,
output?
sir.
GG.
Excuse me, sir.
Yes.
Sir, part C जरा repeat कर दे. Part C.
Okay. What they are asking in part C? Atif?
Sir, part C पे सर से नहीं समझा.
नहीं, what they are asking, क्या पूछ क्या रहे हैं आपसे?
Sir, projection of FOB of F along the line OB.
Means they want projection of F along line OB. यही है ना?
Yes, sir.
अच्छा. So अगर मैं F की प्रोजेक्शन OB के along फाइंड आउट करना चाहता हूँ, प्रोसीजर क्या होगा? जितना आपको आता है वो मुझे बताएं, खैर गलत बताएं, कोई मसला नहीं है. जी आतिफ, अगर मैं एक फोर्स है उसका कंपोनेंट किसी खास
सर
एक्सिस
इसका
पे
समझ
लेना.
नहीं आ रहा है.
अच्छा, तो यही तो मैं आपसे कह रहा हूँ ना, बार बार जब शुरू की क्लास में मैं आपको कह रहा हूँ थ्योरी में कि आप जरा एक्टिव रहे, क्वेश्चन करें, मुझसे पूछें. तो ये तो मैं 50 मरतबा एक्सप्लेन कर चुका हूँ. इफ यू वांट टू फाइंड आउट प्रोजेक्शन ऑफ फोर्स अलोंग एनी एक्सिस, जस्ट सिंपली फाइंड आउट यूनिट वेक्टर. उस एक्सिस के अलोंग यूनिट वेक्टर फाइंड आउट करें. अभी ओ बी पे हमसे पूछा जा रहा है कि कंपोनेंट फाइंड आउट करें, तो ओ बी पे आपने क्या करना है? यूनिट वेक्टर फाइंड आउट करना है, जो कि एन होगा, और ओ बी के एक्सिस है, तो लेट्स से इट इज एन ओ बी. आपके पास आ गया? एक दफा आपके पास एन ओ बी आ गया है, सो आपने क्या करना है, इसका डॉट प्रोडक्ट ले लेना है फोर्स के साथ, एफ डॉट एन ओ बी हो जाएगा। ठीक है, अभी एन ओ बी आपने कैसे फाइंड आउट करना है, तो क्योंकि एन आपके पास यूनिट फैक्टर है, हमने यूनिट फैक्टर फाइंड आउट करना है। अगर हमारे पास वेक्टर हो, इसको उसी वेक्टर के मैग्नीट्यूड पे डिवाइड कर दे, आपके पास यूनिट वेक्टर आ जाता है। ठीक है, तो यहाँ पे ओ बी के अलोंग आपने यूनिट वेक्टर फाइंड आउट करना है। सो ये देखिए डिस्टेंसेस गिवन है, एक्स में ये डिस्टेंस कितना है 6 है, वाई में कितना है ये 6 है, जेड में कितना है 2 है। तो 6, ये देखें 6i 6j और 2k, ये आपके पास फैक्टर हो गया, इसी के मैग्नीट्यूड पे डिवाइड कर दें, ये आपके पास यूनिट फैक्टर हो गया। फोर्स हमने ऑलरेडी फाइंड आउट किया था ना, फोर्स हमारे पास है, तो फोर्स डॉट यूनिट फैक्टर दोनों को मल्टीप्लाई करेंगे, आपके पास ये आंसर आ जाएगा। क्लियर है ना? जी
यस
आतिफ।
सर, सही। थैंक यू
अच्छा,
सर।
अच्छा यहाँ पे देख लें, आ,
यस सर।
ये क्या था, ये एफ, एफ का कंपोनेंट जब एन के अलोंग हम फाइंड आउट कर रहे थे, तो हमने क्या किया था, हमने एफ और यूनिट वेक्टर एन का डॉट प्रोडक्ट लिया था ना। जी, यहाँ पे जरा देख लें सदाम।
यस सर।
अच्छा, ये एक्स्ट्रा एन मैंने यहाँ पे क्यों पुट किया है?
टू शो डायरेक्शन सर,
अच्छा, डायरेक्शन शो करने के लिए। अब्बास जी, वेक्टर वेक्टर शो करने के लिए, ठीक है। अच्छा यहाँ पे देखें, तो इधर तो एक एन ऑलरेडी से मौजूद था, दूसरा मैंने पुट क्यों किया? हुजैफा।
सर डॉट प्रोडक्ट हमेशा स्केल लगाते हैं, तो उसको वेक्टर
ओके,
रिप्रेजेंटेशन
वेरी
देते
वेरी गुड, वेरी गुड, दैट इज वेरी गुड। Okay, we had this f dot n, but to show direction we put another n, although we had one n. Why? Because f dot n will give us scalar, so that will be magnitude, and another n will give us the direction. I hope everyone get this point clear. So now this dot this, it gives us this magnitude. If you want to show, if you want to show direction of this vector ob, fob, so what you can do, you can multiply another n with it, f dot nob, another n with it. So f dot nob is magnitude 84.4, multiply with unit vector, this is the unit vector, and you will get this fob in vector form. Is it clear?
Yes, sir.
Okay, so let's move forward. So now we have imagine we have this vector f, and we want to express this vector in terms of unit vector ij and k. So ij and k, how we can find out fx, fy, and fz and represent it in form of ij and k, and then determine the angle between f and the y axis. So if we have, for example, if we imagine, okay, we will do in the second step. First, what we need to do, we need to find out fx, fy, and fz. So this is x, and this is y, this is z. So this is the force. So the distance from this till this point in x-axis, if you see, it is how much? It is 40. So the x component will be 40i. The distance in y, we don't have distance here, but we have distance here. How much is this distance? 50.
50.
And will it be plus or minus?
Minus.
Minus. So 40i minus 50j, and this is z. So in z we are having how much distance? We are having 110. So you see, this is 40i minus 50j into 110k. This is in vector form. This is in vector form. Okay. Now what will be its magnitude? Magnitude will be 40 square plus 50 square and 110 square. So this is in vector form divided by magnitude. So what we will get? We will get the unit vector along force F. Now take dot product means the force is basically equal to force, or magnitude of force multiplied by the direction. So this is the magnitude of force multiplied by direction, which is basically the unit vector. When you multiply it, we get this in vector form. Okay, now you see this 18.86, this is with I, so this is the fx component, this is fy, and this is fz. What they were asking? They asking determine express f as a vector in terms of unit vector I, j, and k. Okay, so this is the answer. Is it clear?
Yes, sir.
Okay, they are asking to find out the angle between f and x. So what we will do, if you want to find out angle between f and x, so we know that f x is basically equal to f cos of theta x. So theta x will be on one side, and fx should be on other side. If they want us to find out angle between f and y, so that would be theta y. So f, we know that fy is equal to f sine theta y. Cos theta y. So cos theta y will be on one side, and fy and f will be on other side. So you see here, we know that fy is equal to f cos of theta y, and they are asking to find out this thing. Put this one, this theta y on one side, put this cos inverse here. When you find out theta y, it will be this one. Is it clear?
Yes, sir.
Okay. Now we have another question. What they are basically asking, they are asking express f as a vector in terms of unit vector I, j, and k. This one, same question. But in this case, what they have given 2 points, not the angle. Determine the angle theta x, theta y, theta z. So in that case, they were asking only for one. Now they are asking for three. Fx is equal to f cos theta x, fy is equal to f sine theta, f cos theta y, fz is equal to f cos theta z. Like this one, you can find out. Okay, but the problem is, first you need to find out the x, y, and z component. Means you need to write the vector in form of I, j, and k. So how you can find it out? You are having now 2 points. So you remember this equation? You remember this equation? We
Yes, sir.
have force now,
Yes.
and x distance, y distance, z distance. X, let's say, how much will be the x distance? This is x. So how much will be the x distance if you calculate it?
15 minus 25.
It will be how much?
Minus
15 minus 25.
minus 40.
It will be minus 40. Minus 25 minus 15. So it will be minus
Minus
40. So you see here, it's minus 40. Is it clear? And the magnitude of f is given. So you can solve this one by yourself, I think. Clear hai?
Yes, sir.
Yes, sir.
Okay. Okay, now the one was when 2 points were given, the starting and ending point. Now the second case was when 2 angles are given. When 2 angles are given, so you can find out. So what they are asking now, here you see, express f as a vector in terms of unit vector I, j, and k. Determine the projection both as scalar and as vector of f on line OA. What they are asking, f onto line OA. We need to find out projection of f on OA. So they basically, what they are asking, what need to find out? क्या मतलब है इस चीज का?
Projection of F on line OA.
What is this?
FOA find करना है सर.
FO, what will be FOA? Component of force F along OA, right?
Yes sir.
Okay. Which lies in the XY plane. Means OA, it is in the X. Okay, if I want to find out the projection of F on OA, how can I find out? What I will do?
So पहले unit vector find करेंगे OA.
पहले unit vector find out करेंगे along OA, right? And then we will take its dot product with the F. right?
Yes, sir.
Okay. So let's come towards the first one. They want me to write this vector in form of ij and k. So in other words, they want me to find out fx, fy, and fj. Okay, so what can I do? Uh, wait for a while. What they basically you see this one. This is force F. Can I find out this Fz component? Can we find out this one Fz?
Yes, sir.
Okay. So what will be Fz?
F into cos of 40 F.
F into
Five
cos of
percent of
40. Okay. Okay. So the other component will be sine of 40, right?
Yes, sir.
Okay. So the other component will be sine of 40. So the other component, it can be this one. So let's give it a name fxy or fh, whatever name you want. Let it be fh. So fh will be f sine of 40. Okay. But since x in this direction, y in this direction. So this component, it is fh. This is fz. Okay. Now we have fh, we have fz. Do we have fx, fy? We don't have at the moment. Do we have it? Okay. Now this fh, whether it's making any angle with the y-axis,
Yes, sir.
can I find out this fy now? G, can we find out fy? If this is fh, we already find out fh. We have this angle. Can I find out this fy?
Yes, sir.
Okay, what will be fy?
Sir,
G,
FH cos of theta.
f it will be fh cos of 35 degree, right? Okay, what about fx? What will be fx? Fx, it will be sine 35, but one component will be in this direction, that is y, and one will be in this direction. Since it is opposite to x, so it will be minus, right? Fh was 3.21, so this one will be 3.21 sine of 35 with minus sign, and fy will be cos of 35 into 3.21, which is fh basically. Is it clear? So now I have this x component, now I have y component, I have z component. I can write it like this. What they want me to do to find out this component of force F along OA. So find out unit vector along OA. So it is very much easy. Like we have force F, and we want to find out this unit vector along OA. So how I can find out this unit vector along OA? You can how I can find out the unit vector or the vector along OA? It's very much simple. For example, this is OA. So OA is in XY plane. It doesn't have any component in Z plane. So find out its X component. So the X component, it will become N OA cos of 30 degree, and this component will become N OA sine of 30 degree. So N is the magnitude, so it will be having value 1. So I will take NOA as a common, or magnitude of NOA as a common outside, and inside will be cos of 30 degree sine of 30 degree. And instead of n, I will put 1. Is it clear? So that will be the unit vector, and then multiply this f with NOA, and you will get this one. So this is in scalar form. Now what they want me to write it down in terms of vector. So to convert this scalar into vector, again multiplied with a unit vector. So same unit vector again, and you will get this same FOA in vector form. Is it clear? Okay. So here the force has a magnitude of 900 Newton and acts along the diagonal of parallelepiped as shown. Express F in terms of its magnitude times the appropriate unit vector and determine its x, y component. So it's very much simple. What you have to do, you have to find out uh, what they are basically asking. Express F in term of its magnitude time. So you have to represent that F means F magnitude is 900 and you have to multiply it with the unit vector along that F to show its direction. So how you can show? You can need to find out this direction. So this one, if it will be having three components, one in X, so the X component will be in this direction, that will be positive, and the Y will be in negative direction, it will be minus Y. So minus Y is -4 and X is 2, and in Z direction again it's an opposite direction, so it's -4. Okay, 4I, remember here the units are in LB and over here the units are in meters. So but the X value will be how much? The X will be 2I minus 4J and minus 4Z. 2I minus 4J minus 4Z. These are in foot-pound system, so you don't have to write these values. It will be 2I minus 4J and minus 4K divided by 2 square plus 4 square plus 4 square, square the root. And so you will get the same answer like this one, but instead of 300 over here, you will be having 900. Answer is given over here. Okay. So when you multiply it inside, you will get fx, fy, and fz. Multiply it here, so it will become 300. Multiply it here, it will become 6, and it will become 6. So these are the components, right? So you don't have to use these values. You have to use the values given in the question. But this one is just for concept developing. Means by looking at the solution, you can get this concept that how to solve this problem.
सर
Right?
-4 क्यों लिया?
-4 क्यों लिया? The force direction is from here to this one, right? So x means in x, if you want to move from here to here, so this means x is in this direction. Okay, so x is positive, y is from here to here, so it should be positive or negative?
नेगेटिव सर, यस सर, समझ आ गया.
Okay, so same is for the z. Okay, now here the turnbuckle is tightened until the tension in the cable AB equals to 2.4. So here we are having a cable. Okay, so here we have the turnbuckle. We tight it, so we can lose it, we can tight it. So what they say, we made it so tight that due to this, a tension developed in this wire, and that tension is applied on this element AB. So the tension in the cable AB equal to 2.4 kilonewton determine the vector expression for the tension T as force acting on the member AD. Also find out the magnitude of projection T along line AC. What is this? Projection of T along line AC. What we will do for this one? Find out unit vector along AC, which will be NAC, and take its dot product with T, right?
Yeah.
Okay, so the magnitude of T is already given, which is 2.4 kilonewton.
Sir, repeat the question, please.
Okay, read the question, what they are asking. G, what they are asking. क्वेश्चन किसका था यार? उसामा आपका था क्वेश्चन?
यस सर. ओके सर, समझ आ गई है.
आ गई है ना? Okay.
Yes, sir.
So what they are asking basically the component of force along line AB. So हमने क्या करना है? We will find out unit vector along AB and we will take its dot product with T. So by doing so, what we will get? We will basically get the vector along that axis. Okay, so they basically solve that thing. So what they are asking in first case, they are asking tension equal. Okay, first they are asking to find out the tension in this one, the vector for tension in this cable AB. So how we can find out vector multiplied by its magnitude? So vector is basically magnitude multiplied by direction. So for direction, we basically use the unit vector. So this is the magnitude, this is the unit vector. How we can find out this unit vector along AB? So we have distances. Okay, so in x-axis, how much is the distance from this point till B? This is 2 meters, right?
Yes, sir.
Okay, in y-axis, how much is the distance between A and B? How much?
3 meter.
It is 1 meter, 1 meter, not B and C. I'm asking about A and B. It is 1 meter. Okay, 1J. And along A and C, along A and B in z-axis, if you see, this one is 5. Okay, so this is the vector, this is the magnitude. Combine it, you will get. This is the distance in y direction from A to B. Okay. Okay, so when you find out this one, you will get this vector T. We get this vector T. What we need to do, we need to find out now the unit vector along AC. So what will be unit vector along AC? So distance in x-axis along AC, it is 2. Distance in y-axis, distance in y-axis. So from A to C, how much is the distance in y-axis from A to C? This is the distance from A to C. This is 3, this is 1. 3 minus 1, it will be 2. Okay, so this one will become जी
इस पे समझ नहीं आई सर.
किससे समझ नहीं आई?
This is from A to C.
From A, अच्छा, from A to C आपने डिस्टेंसेस फाइंड आउट करने हैं ना, from A to C. So from A to C x पे कितना डिस्टेंस है? ये देखें, ये पॉइंट A है, अगर ये C है तो x में कितना डिस्टेंस है और C के दरमियान? ये 2. ठीक है, ये A है और ये C है, तो इसमें y में कितना डिस्टेंस है? आपने नेगेटिव डायरेक्शन में जाना है, कितना डिस्टेंस है? ये 3 है और ये 1 है, तो ये इससे निकाल दें, ये 2 रह जाएगा. ठीक है, माइनस डायरेक्शन में जा रहे हैं, सो -2. z में कितना है? फ्रॉम A to C. ठीक है, नेगेटिव डायरेक्शन में आ रहे ऊपर से नीचे, तो ये -5. ये डिवाइड बाय मैग्नीट्यूड, ये आपके पास यूनिट वेक्टर आ जाएगा. इसका डॉट प्रोडक्ट लें किसके साथ? टी वेक्टर के साथ, आपके पास प्रोजेक्शन का मैग्नीट्यूड आ जाएगा. इज इट क्लियर?
Yes, sir.
Okay, so the rigid pole cross arm assembly is supported by 3 cables as shown. A turnbuckle at D is tightened until it reduces tension in CD of 1.2 kilonewton. Express T as a vector that it makes any difference in the result which coordinate axes are used. Okay, what is the question? This is the diagram. Over here we are having this cable from C to A. So the rigid pole across assembly is supported by 3 cables as shown at A. No, is supported by 3 cables as shown. A turnbuckle at D here is tightened until it induces tension T in CD. Means आप क्या करते हैं, इसको टाइट करते हैं until induces tension 1.2 kilonewton in CD. Express T as a vector. How we can express T as a vector? To find out the unit vector along this one and multiply it with 1.2. So unit vector will be how much is the distance in y direction. In y is 3, and in z in x it is from this point till this, it will be 1.5. In y it is 3, and in z how much it is? It is 3 plus 1.5, so minus 4.5. So this is the vector divided by its magnitude. This is the unit vector, multiply with 1.2. So you will get this t, express t as a vector. Clear till this one? यहाँ तक clear है? Okay, now they are asking 4.5 की समझ नहीं आई। ये देखिए यहाँ से लेके यहाँ तक ये डिस्टेंस है ना z में, ये कितना है? ये टोटल डिस्टेंस है ना ये वाला। तो ये 3 है और ये 1.5 है।
ठीक है सर।
तो ओके, नाउ ये देखिए हमने एक्स वाई जेड कोऑर्डिनेट यूज किया ना। एक्स किधर है? एक्स ये है, वाई ये है, और जेड किधर है? जेड ये है। तो ये कह रहे हैं कि अगर हम एक्स की बजाय एक्स वाई जेड की बजाय एक्स डैश वाई डैश जेड डैश यूज करें, कोई मसला होगा? तो लेट्स सी, दिस इज एक्स डैश, दिस इज वाई डैश, और एंड दिस इज जेड डैश। तो ये तो दोनों सेम डायरेक्शन में है, तो हमारी तो ना डायरेक्शन में कोई फर्क पड़ेगा ना कोई मैग्नीट्यूड में फर्क पड़ेगा। सो नो, देयर विल बी नो डिफरेंस, डिफरेंस कोई भी नहीं पड़ेगा, बिकॉज both axes are like same for these cases. So the two indicated coordinate system are equivalent for the question, so that's why there will be no difference. So does it make any difference in the result which coordinate system is used? No. Is it clear?
सर ये 4.5 के साथ
ये x2 ने x
शायद आपकी साउंड क्वालिटी बहुत ही बेकार है, बहुत शोर है जी। x2 किसका क्या x2 है? x2 ये क्वेश्चन किसका था यार? देखिए what they are asking, they are asking for tension in cable CD, right? So what we need to do, we don't have to do anything with this one. We need to find out unit vector along CD. So unit vector along CD, this is origin, this is okay, this is point D, this is point C. So how much is the distance in X from point C to D? So D is this one, this is C, this is basically the X distance from C to D. So is it 2 or 1.5? You need to look at your target vector, your targeted line, not at your diagram. The diagram को आप देखेंगे, so then in y-axis you will see that this is 1, this is not 3 meter. लेकिन आपने डायग्राम में रैंडम वैल्यूज तो पुट नहीं करनी, you have to look at your targeted points, उन दोनों के दरमियान आपने डिस्टेंसेस देखनी है। Okay, should I move forward?
सर ये z एक्सिस नेगेटिव के लिए है।
क्यों आपके ख्याल में क्यों लिए?
सर नहीं समझ।
What is direction of vector?
सर डाउनवर्ड
जी
है।
डाउनवर्ड है, और z पॉजिटिव कहाँ पे?
अपवर्ड है।
तो नेगेटिव लेना चाहिए नहीं लेना चाहिए?
लेना चाहिए सर।
ठीक है,
ठीक।
okay, so now let's see another problem. This one is simple, I think आप इसको खुद कर लें. The tension in supporting cable AB is 10 kilonewton. So here they say the cable AB is having tension of 10 kilonewton. Write force with the cable. Write the force which the cable exert on the boom BC as a vector T. Okay, again, what you need to do, you need to find out the component of this force along this one, along this axis. So find out an AB, multiply with this one, you will find it out. Okay, means find out the unit vector, this one, find out this vector, take their dot product, तो आपके पास आंसर आ जाएगा. So first find out this T in form of vector, we find it out, and then take its dot product with this one, so you will find it out. Okay, let me repeat the question, what they are asking. The tension in supporting cable AB, oh, in this one, it is 10 kilonewton. Write the force which the cable exert on the boom, not on this one, on the boom. This is directly the tension over here. So just simply we are having T is equal to 10 and multiply it with the unit vector. So unit vector can be, just simply find out the xyz distance. So it will be xyz divided by magnitude. Yes, this is the answer, direct answer. Determine the angle theta x, theta y, and theta z. So we already know how to find out theta x, theta y, and theta z. So the cos of theta x is equal to this component, cos of theta y is equal to this component, cos of theta z is equal to this component. From here you can find out the angles. Right?
Sorry, -1.5 minus.
किधर है यार -1.5? -7.5.
-1.
Okay, so y direction is this one, right?
Yes, sir.
Okay, or and the force vector, the tension, since it is tension, so it will be in this direction, right? From here till this one. Okay, so I mean the y component will be from here towards here. You have to move in negative y. Clear hai?
Yes,
Yes,
sir.
sir.
Okay. Now here what you need to do in this problem, they basically ask you determine the angle theta between 200 Newton force and line OC. Oh, force between 200 and OC. So by looking at it, it looks very difficult. But you know that if we find out the unit vector and OC, and we have this F, so take a dot product like A dot B is equal to AB cos theta. So F dot N will be equal to Fn cos theta, and cos theta will be equal to F dot N divided by F, something like this. You can find it out by this one. Okay, so what we need, first we need to find out the vector F. Is it clear? Let me repeat. What they are asking, they want you to find out the angle between F and line OC. So अगर आपको procedure ना पता, if you don't know the procedure, so this question will become too much difficult. Like if you imagine this one graphically, it looks very difficult. So but we know the simple step. Like we have this force, and what we will do, we will find out the unit vector along line AB. So we will get this in vector form. Okay, so like in X, how much distance do we have from here till here? This can be 120 minus 120 mm. And in Y, how much distance we will be having from here till this one? It will be minus 240 plus 240. And in Z we are having plus 80. But remember, these are in mm, and over here the units are in lb, so that's why the values here are changed. Instead of 120 they put 12, instead of 240 they put 24, instead of 80 they put 8. So you have to be consistent in unit, you have to use these values. Okay, vector divided by magnitude, find out this one. Okay, so you will get F in vector form. Now what you need to do, you need to find out this OC, vector OC. So for OC vector, what you have to do, you basically need to find out the X distance, which is 120, and the Y distance. How much is the Y distance? That will be basically 240. And how much is the Z distance? In Z we don't have any distance, so just 120I, 240J. Okay, I am talking about this value, not this one. So the angle between these two, F and OC, take their dot product. F dot OC is equal to FOC cos of theta. Take theta to one side and this one to other side. Solve it, you will get this angle. Is it clear?
Yes, sir.
Okay, so this is end of today's class. If you have any question, you can ask me.
Sir, please
सर
explain
पेपर
how
के
can we determine.
Okay,
साइकिल आप कर लो सवाल.
सर अगर आप पेपर के हवाले से थोड़ा बता देंगे कि मतलब कि किस तरह का
और
पेपर होगा, कितने टाइम का होगा और क्या.
ठीक ठीक मैं बताता हूँ. Okay, so
Sir, how can we determine distance when there are many directions? Like we were facing many confusions while determining the x direction and y direction.
you have to look at the coordinate axis. Means if the line is inclined, so you have to check. For example, you are having 2 points, so in between 2 points you have to look at the axis, that if I want to find out its component in this axis, so how much distance I need to cover in x to reach this point. So उस basis पे आपने वो find out करना होगा. ठीक है?
ठीक है sir.
Okay, let
Thank you.
me share entire screen. Okay, if you go here, date sheet for midterm exam. So date sheet has been given here, and I have put it over here, some instruction for you people. Midterm course include all course from start to lecture number 8, means today's lecture. Whole course is included, means from the very first one, the first that we did in university in class, from that one till now, whole course is included. Okay, remember, if you attend all classes, if you go through all your classwork, if you understand it, if the concept is clear, so you can do 100% midterm exam, you can get full marks. But remember, don't expect that I will give same question from the same book or the same question that I have done in the class. Okay, the questions concept will be the same if you have attended all the classes, if you know the concept, if you have practiced all those problems which I told you to practice, you will be able to solve your exam problem. But it will not be exactly the same problem. I may generate problem from my own side, I may take it from some other books, but it will not be exactly copy paste type of question. Okay, there will be two parts of your exam. One will be quiz type, and other one will be take home exam. 10 marks will be for the quiz and 10 marks will be for the take home exam. In take home exam, I will post few questions. I will put the paper here. For example, if you go to classwork, so in classwork we have date sheet for exam. Over here we will be having another term that will be midterm exam. So for example, in next week, before a day or two before, I will post over here about that, at what time I will post your exam paper. Means for 8th semester, what I did, I posted on Friday. You are also having your exam on Friday. I posted the MCQs type at 10 a.m. and the MCQs test was for it was like quiz type MCQs, and it was for 15 minutes. So the quiz started at 10. What they did, they came here, they click on the quiz, they started the quiz, and at 10:15 the quiz ended. So before 10:15 they had to submit the quiz. That was for them. Okay, and then at 11 I uploaded another paper that was take home exam. What they did, they downloaded that paper, solved it within 24 hours. Means I given them 24 hours time. They solve it, they take its picture and then submit it again to me over here in the Google Classroom before 11 a.m. of next day. Within 24 hours they submitted back to me. Okay, so you have to do it the same way. So what I will do, like for, let me show you instruction for them. For example, the midterm exam of maintenance engineering schedule on this will be of two parts. Part one will be quiz of marks this much, for which this much time will be allowed. The quiz will upload it in the midterm exam section of classwork at 10 a.m. You all need to attempt and submit before 10:15. Part two will be take home exam of 50 marks, for which maximum allowed marks will be this much, and will be 50 and time will be 24 hours. It will be uploaded in this section at this time. You need to write it down and submit it before at this time. Make sure not to copy or show your exam to any other student. A small percentage of similarity in writing, content, wording can cause cancellation of your exam. For take home exam, you may need to search your books, slides, online, internet for the required data. So ये चीजें use करने की इजाजत. So this is just an example I have given you. आपके लिए instruction different होगी. ठीक है, आपने क्या करनी होगी, अपने जो गूगल क्लासरूम है इसको टाइम टू टाइम आपने चेक करते रहना। सो यहाँ से आपको सारी इंफॉर्मेशन मिलेगी। सो मे बी बिफोर योर एग्जाम 1 2 3 4 डे बिफोर, या एक दिन या 2 दिन या 3 दिन पहले सारी इंस्ट्रक्शन पोस्ट हो जाएगी आपके गूगल क्लासरूम पे, आप उसको पढ़ लें। एंड जो जो टाइम मेंशन होगी उस टाइम पे आपने बैठना और गूगल क्लासरूम के क्लास 4 में जाके मिड टर्म सेक्शन में पेपर चेक करना है। जी हिलाल,
जी तो सिमिलरिटी होगी ना सर?
अच्छा बताता हूँ जी। निमरा, निमरा क्वेश्चन करें।
सर क्विज भी न्यूमेरिकल बेस्ड होगा, फिर उसके लिए टाइम कम नहीं होगा सर?
वो मींस आपको जब मैं क्विज दूंगा उससे पहले मैं उसको खुद सॉल्व करूंगा, जितना टाइम उस पे लगेगा वो मैं आपको बता दूंगा। मोस्टली इट विल बी एमसीक्यूज टाइप। हिलाल सिमिलैरिटी इस तरह है, आप खुद सॉल्व करें तो आपके राइटिंग में, आपके मेथड में, और ठीक है जब आप प्रॉब्लम खुद सॉल्व करते हैं या कोई और दूसरा बंदा खुद सॉल्व करते हैं उसमें जमीन आसमान का फर्क होता है। ठीक है, वी कैन अंडरस्टैंड कि कितनी सिमिलैरिटी हो सकती है क्या नहीं हो सकती। लेकिन अगर आप दूसरे से टेक होम एग्जाम लेके उसको खुद कॉपी करके आगे पीछे कर लेते हैं तो उसका हमें अंदाजा हो जाता है। ठीक है, so you are now engineering student, you already understand कि what I mean from similarity index। if अगर आप किसी और से करते हैं, अगर आप वो खुद कर लेते हैं वो खुद ब खुद उसमें रिफ्लेक्ट हो जाता है। इज इट क्लियर नाउ? ओके
जी
ओके, मैं रिकॉर्डिंग स्टॉप कर देता हूँ अगर आज के लेक्चर से रिलेटेड कोई क्वेश्चन नहीं है तो।